Well, in this video, we are going to make the comparison between four dependent methods. So, to illustrate how it might be carried out using Jamov, we are going to load the spreadsheet methods. Well, in here we have 11 samples that were analyzed using four different methods. We have the liquid chromatography coupled to UV detection, liquid chromatography coupled to mass spectrometry in tandem. We have the liquid chromatography with the ultraviolet detection using derivatization, and gas chromatography coupled to mass spectrometry with derivatization. So in here, we have now four methods. I want to compare the four methods. And the first question that I showed the answer was, choose four methods provided equivalent results. Um, if the tests, I can use the repeated Missouri ANOVA, or I can use the Friedman test to answer this question. If the answer was yes, it is finished. The four methods were equivalent. But if the answer was not, I cannot say what of these methods were different. For example, I might have these three identical, statistical equivalent, and this one different from all the others. Or this one is different just of this. To I found these specific differences between the pairs, I must use the post-hoc tests. You must keep in your mind that post-hoc tests are very sensitive. In other words, if your data was not normally distributed, uh, if the assumption of sparsity was not found, the 2K test has a great probability to provide wrong results. So we're going to analyze this data set. We go to exploration, descriptive statistics, and we're going to add the four methods in here. We have 11 observations. None of the observations has troubles. The software can understand all the results provided, all the results which were imported from Microsoft Excel. I go to statistics. I can put the interquartile range. And they can see that the four methods provided the close results. At this point, the students always say, oh, professor, I don't need to do any hypothesis test because the descriptive statistics says to me that the four methods are equivalent. But we must check because you already have talked a lot about this in other videos of this playlist. Sometimes you have values that were numerically close, but the standard deviations were too small. When the standard deviations were too small, you can have different methods. You can have different methods. They provide close numerical values, but they are statistical different because they have small standard deviations. So I can go to ANOVA. I go to repeated Missouri ANOVA. I'm going to enter my variables. First, here I put the methods. I am comparing four different methods. In here, I will place liquid chromatography coupled to ultraviolet detection, liquid chromatography coupled to mass spectrometry in tandem. Uh, I just put the width in here. And you know that when it was with, it's with derivatization. I will add my variables. Oh, I did something wrong in here. I put the wrong command. Let's we do it again. Well, now it is done.
Yeah.
Well, the repeated Missouri shows to me that the four methods are not equivalent. There is some difference in here. Well, the repeated Missouri shows that the four methods are not equivalent, but they cannot say where was its difference. So I must use post-hoc test to find these differences. But in first place, I can determine if I can really use a parametric test. Well, I go to assumption checks, I go to Sparrows tests, and the Macaulay's test said to me that the sphericity of the data was found. We can check the sphericity of our data sets. I can go to the key plots, well, and I can see a deviation from normality. Now, anyway, I believe that the Friedman test is the best option than the repeated Misdreunov. We have a classical example when you have close numerical values, but statistical different results. I can go to post-hoc tests, and I can use the Bonferroni test that is not so susceptible as the 2K test to sphericity violation. I make the post-hoc test, and they can see that the greatest differences between those methods. For example, LCUV with derivatization is equivalent to GCMS with derivatization. LCMS is equivalent to LC, to liquid chromatography coupled to ultraviolet detection. And it was also equivalent to gas chromatography coupled to mass spectrometry. Well, here we have the comparisons, and you can see, for example, that liquid chromatography with ultraviolet detection provide results different from liquid chromatography to mass spectrometry. Well, in another example of this playlist, since the numerical difference between the methods was very small, parametric and non-parametric tests provided close results. But in this case, we are going to see if a parametric and non-parametric tests might provide different interpretation of the results. So I believe that the Friedman test is a better option since I can see a great deviation from the normality. I go to this push-up button and I go to the Friedman test. I put my four methods in here, and the Friedman test also show that the four methods were not equivalent. Let me see what the Turing Hanover tests are going to show. Well, we find that liquid chromatography coupled to the detection was different from gas chromatography coupled to mass spectrometry. What the home test, what the Bonfer home test shows to me when we're going to compare. Well, the difference finding between these two methods was not so critical, using a parametric and a than a non-parametric test. For example, the difference between this liquid chromatography to gas chromatography coupled to mass spectrometry is great in here, but it was not so great using a parametric test. We can see that the great difference between these methods was between liquid chromatography coupled to ultraviolet detection and liquid chromatography coupled to mass spectrometry in tandem mode. This difference is very brutal in here, but well, this difference is also pronunciated. The difference was also fine using a non-parametric test, but the difference is more pronunciated in here. Oh, as you can see, the data have deviated from the normality. The data has deviated from the normality. The Friedman test was used since the data was not normally distributed. The Friedman test had shown that the four methods don't provide equivalent results, and the post-hoc test, the non-parametric post-hoc test, the Durbin-Conover test, can found the differences, specific differences between the methods. And you can see that the difference between these methods were pronunciated. More. Now we're going to another video of our playlist.